Contour shader settings for materials combined with the contrast shader options can change the look of your contours as you desire. For example, some of the contour characteristics you can control are color, uniform or based on distance, line thickness, constant or based on distance or light direction, reflections, which can have or not have contour, lines for geometry, materials, or color edges. Okay, now let's see how to get some of these effects, starting by looking at the parameters of the contrast shader. As you saw earlier, the contrast shader decides where the contours need to be traced. This decision is based on the data collected by the store shader, such as depth, surface orientation, and color. Depth can be used to find edges of objects. In cases where the depth difference between samples is high, it means that the end of a surface has probably been hit. So now you are looking at a different object or surface or the background. The surface orientation feature can find edges of a curved surface. When the change in orientation is above a certain threshold, an edge can be traced to highlight that surface feature. A change of materials or a more generic change of contrast can be used to trigger edges also. The minimum and maximum level parameters deal with reflections and refractions. If both minimum and maximum levels are set to 1, only contours of non-reflected or non-refracted objects are traced. If the maximum is set to 2 or more, reflected and refracted objects also receive contours. If the minimum is set to 2, only reflected or refracted objects receive contours. Note that for refractions, you might need higher values than 2 if rays go in and out of the two surfaces of a transparent object. If the minimum is set to 2, only reflected or refracted objects receive contours. Once the contrast settings of your contour are set and contours appear where you want them, it's time to play with the actual look of the contours. This is achieved by assigning different contour shaders to the materials and playing with their parameters. There are a few material contour shaders available in Mental Ray. You will only be introduced to a selection of them, since others are variations or combinations and have similar parameters. The most basic material contour shader is Simple Contour. It has only 2 parameters, color and width. One single value for width means that all of the contours generated will have the same thickness. The width parameter in this shader, and in any other shader, is measured as a percentage of the image width, so that it maintains the same relative thickness if the image is rendered at different sizes. Other material contour shaders use variable line width based on distance or light direction. For example, the width from light contour shader changes the width of the contour based on the amount of light that hits the surface. This can simulate a very common technique of tracing heavier contours where the shadows are and lighter contours where the lights are stronger. The depth fading contour shader changes the width of the contour based on the distance of the object from the point of view. It's often desirable that distant and smaller objects have thinner lines to prevent their edges from blending together and destroying details. You will find settings for the minimum and maximum distance range and width settings for the closer and farther values of the distance range. Contours within that range will have a thickness interpolated between those values. This shader can also change the color based on the distance. You can set 2 colors. The contour line's color will be interpolated based on the distance of the object and the range specified. A special shader called the combination shader merges features from other contour shaders into a single one. This gives you control over distance settings for color and width. It also provides control over the width based on light and shadows. Curvature is another factor that can be used to drive the contour width. The curvature-dependent width shader traces edges with thicker lines where the curvature is more pronounced, and with thinner lines where more smooth. There are more shaders available to control contours based on material colors or animated settings which interpolate over time. There are also variations of the shaders described earlier.